Hello, friends. Welcome to our live broadcast. I'm Alan. Today's live stream focuses on a core topic construction of steel box girders for long span highway bridges. First, let me provide an overview of our company. Our company, Shandong Boyoun Heavy Industry, was founded in 2006 and focuses on the R&D, fabrication, marketing, on-site technical services of steel formwork for bridge, viaduct, tunnel engineering. The headquarters and main factory are located in Binzhou City of Shandong, China, with the international department located in Beijing. The annual output is more than 75,000 tons. Boyoun has been qualified by ISO QM system since its foundation. More than 30 patents have been approved each year. Boyoun has served over 1,200 infrastructure projects, mainly for high-speed rail, expressway, railway, highway, and other large-scale infrastructure projects. We experienced formwork solutions, cooperated with giant state-owned enterprises and well-known overseas construction groups. Over the years, we have gained extensive experience and expertise and built a strong reputation in the industry. We are dedicated to providing our customers with high-quality products and, more importantly, with excellent service and technological innovation. Second, overview of long-span steel box girders. Steel box girders are a common structure from in long-span bridge engineering. They are closed structure systems organically connected by top plates, diaphragms, bottom plates, wipes, and stiffeners through full welding technology as shown in Figure 1. Among them, the top plates form an orthotropic deck by combining longitudinal stiffeners and cover plates, which exhibits excellent load bearing and fatigue resistance. Diaphragms and stiffeners work together to enhance an overall stiffness of the box girder and suppress local deformation. In partial construction, the rational application of long-span steel box girders not only optimize the mechanical properties of bridge structures, but also adapts to various advanced construction technologies such as incremental launching, pulling, and cantilever erection. It is particularly suitable for complex construction scenarios such as urban overpasses and river crossing, sea crossing bridges, and has become one of the core structural forms for main girders of modern long-span highway bridges. Third, key construction technologies for long-span highway bridge steel formwork box girders. To effectively address these challenges and ensure the safety, quality, and efficiency of construction, it is crucial to adopt scientific and targeted core construction technologies. Then we will focus on five key technologies in the fabrication and installation of long-span highway bridge steel box girders, including pre-assembly, manufacturing process, cantilever erection, general installation, and pulling installation, elaborating on their operational essentials and application requirements to provide technical support for engineering practice. Steel box girder pre-assembly. Pre-assembly of steel box girders is mandatory before factory delivery with the following core purpose: correction of bridge deck or deck length. The actual dimensions during pre-assembly are adjusted by calculating the lines difference between the top and bottom plates of each girder segment. Segment pre-assembly of steel box girders. During pre-assembly, 5 girder segments must be assembled into an integrated unit. According to drawing requirements, gaps shall be reserved between segments to match the connecting parts of adjacent segments, followed by welding of pre-assembly walls. After passing inspection, the previous steel box girder unit is shipped out, while one segment is retained for pre-assembly with the next unit. The pre-assembly sequence must be consistent with the on-site installation sequence, and no modification of segment numbers is allowed during installation. Correction of total length of steel box girders. After the pre-assembly of each unit, its total length is measured and compared with the theoretical lines. Any deviation can be corrected in the next pre-assembly unit to avoid error accumulation. Interface trimming. The dimensional deviation of segment ports is trimmed to ensure collaboratability during installation prior to welding. Manufacturing process of steel box girders. In the manufacturing process of long-span steel box girders, the standard production flow for components is as follows: blanking, straightening, plate splicing, welding, defect inspection, fitting assembly, final assembly inspection. During the specific design and production phase, strict quality control must be implemented for component manufacturing in accordance with the above standard procedures. Since the steel box girders of viaducts are parallel to the roof panels, the transverse slope is fully formed by rotating the box girders. Steel reinforcement blocks and crossbars shall be fabricated in accordance with drawing sequence. With accurate and reliable relevant data, on-site positioning lines uh, shall be established, and precise assembly shall be carried out in compliance with relevant standards and requirements. To ensure the production quality of long-span box-type steel girders, all manufacturing and assembly work shall refer to the technical specifications for highway bridge construction as the reference standard, and illegal construction is strictly prohibited, particularly during welding, and actual welding quality must meet the Class 1 and Class 2 weld quality standards specified in the above specifications. Ultrasonic testing and X-ray testing shall be performed promptly after welding. During construction, the service life of the surface coating of steel box girders exported exported to the atmosphere must be maintained for more than 25 years, and the humidity inside the box girders shall be kept above 50%. Cantilever erection construction technology. There is a wide variety of hosting equipment, which is mainly located in the uh, median strip of linear bridges. The projection surface of some segments falls within the median strip, making it unfavorable to set up temporary supports. Therefore, during the selection of hosting schemes, the cantilever erection method can be adopted for certain segments. Before the cantilever erection of steel girders, a simulated installation process can be conducted first. The plate units of the main girder are analyzed and calculated using the MIDAS construction program to verify the feasibility of the construction scheme. During construction, peer-related devices and double-sided uh, auxiliary supports shall be used to increase the length of cantilevers on both sides to a certain extent, and each corner only needs to be lifted once. Cantilever erection construction technology is thus conducive to ensuring the safety of construction operations. To effectively exert the role of cantilever technology, construction personnel must strictly assemble the steel box girders on the ground in accordance with requirements. The assembly effect of the engineering structure can be effectively guaranteed under the action of ultra-high crossbeams, which plays an important role in construction. Construction units should attach great importance to this technology and ensure its proper implementation during concrete construction. Construction personnel shall erect the main box girders properly. Steel box girder installation. During the installation of steel box girders, the standard erection process is as follows. Survey the construction site to fully understand the on-site uh, topographical information and avoid potential safety hazards during installation. After completing the on-site survey, conduct setting out and install the steel pipe columns. After the installation of steel pipe columns, inspect their bearing capacity and stability to ensure compliance with relevant specification requirements. Hoist the steel box girders and weld them span by span. After welding, once the weld quality meets the standards, paint the steel box girders and finally remove the supports. Long-span steel box girder construction is usually large-scale and not suitable for on-site fabrication. To ensure construction quality and progress and reduce construction difficulty, prefabrication is generally carried out in accordance with design requirements. After prefabrication in the factory, the girders are transported to the construction site for installation. During installation, the bearing capacity of hoisting machinery must meet relevant standard requirements, and 200-ton crawler cranes are generally used. In addition, the installation shall be carried out in strict accordance with the standard procedure. Transverse frames are installed from the center to both sides, and vertical frames are installed from near to far. Before installation, an environmental survey shall be conducted to understand the local terrain. and a suitable installation scheme shall be selected in combination with the characteristics of the engineering structure to ensure the smooth and safe progress of the installation construction. Furthermore, due to the small hoisting radius of this bridge section, the crane is likely to collide with surrounding walls during hoisting. Therefore, the selection of 200-ton crawler cranes is appropriate. Putting installation construction technology. During the installation of long-span steel box girders, influencing factors such as the traction system and reaction supports should be fully considered. To ensure the assembly efficiency of long-span steel box girders, targeted assembly construction schemes have been implemented. To smoothly carry out the construction plan, the role of steel boxes in the construction process should be fully exerted. First of all, construction units should select construction personnel with strong professional skills and rich experience to fully engage in the application of pooling construction technology, ensuring the smooth progress of the project. The specific construction operations, construction and technical personnel must meet the following requirements. 1. Conduct a comprehensive inspection before pooling. Set up benchmarks on each temporary pier to better observe settlement, ensure the integrity of the line, and confirm the presence of the personnel to uh, prepare for pooling. Jog the system 2 to 3 times as required to inspect the relevant hoisting facilities. When measuring resistance, construction personnel need to make appropriate adjustments according to the frictional resistance and calibrate the jacks and oil gauges as required. During concrete construction, if the girder remains stationary even after the maximum pulling force is applied, relevant personnel must conduct an in-depth inspection, and the jacking operation can only be continued after the pulling force is clarified. Quality control measures for long-span highway bridge steel box girders as according to ensure the implementation of technologies and guaranteeing the safety, stability, and service life of bridges, construction quality control is of great significance. This article focuses on key dimensions such as technical preparation, manufacturing quality, and welding deformation control, and and precise targeted control measures to provide reference for particular practical construction. Conduct adequate technical preparation for the construction of long-span continuous steel box girders in complex traffic environments. It is necessary to focus on formulating two core plans to ensure construction safety and quality. Special construction plan for steel box girder installation. Before installation, comprehensive planning shall be carried out with design documents as the core and in combination with the general construction organization design, and the plan shall over construction deployment. Precise precise guidance, quality inspection standards, safety guarantees, and emergency plan. Clarify key contents such as transportation and hoisting parameters, assembly precision requirements, and temporary support standards. Refine inspection indicators such as raw material inspection, component processing, and node assembly, and formulate protective measures for risk points such as hoisting and high altitude operations. The plan can be implemented only after expert demonstration and approval. Special traffic diversion plan. Most long-span bridges are located in busy traffic sections. The construction unit shall communicate with traffic management, road administration, and other departments in advance to grasp the surrounding traffic flow, road network distribution, and other conditions, and formulate a diversion plan in combination with the construction period and enclosure scope. The plan shall uh, clarify traffic guidance rules, traffic sign and marking settings, personnel allocation and inspection mechanisms, and shall be published after approval by the traffic management department to reduce the impact of construction on citizens' travel. Control manufacturing quality. The manufacturing quality of steel box girders directly determines the subsequent construction and structural performance. So it is necessary to strengthen the control of key links such as deflection calculation and formwork precision control. First, accurately complete deflection calculation and pre-bending dimension determination. Technical personnel shall comprehensively analyze influencing factors such as traffic load, structural dead weight, welding deformation, and temperature change. Establish a mode for accurate calculation through professional software, and determine pre-bending dimensions that take both stress rationally and construction feasibility into account. Ensure that the design alignment requirements are met after installation, and guaranteeing driving smoothness and structural stability. Second, strictly control the precision of the formwork. According to the deflection calculation results and structural curvature, determine the precision parameters of the formwork such as elevation, plying position, and verticality, and use the deflection distribution method combined with the parabola equation for detailed calculation to accurately locate the support points. During manufacturing, high precision instruments such as total stations are used for real-time monitoring and adjustments, and the spacing between steel longitudinal and beams transverse beams is controlled within 2 meters to ensure rigidity. After the formwork installation is completed, a preloading test shall be carried out to check the stability and bearing capacity. Welding deformation control process for butt joint of steel box girder plates. Welding deformation of steel box girder plate butt joints will directly affect the structural dimension precision and mechanical performance. So full process control from pre-welding, welding to post-welding is required. Three key points shall be controlled in pre-welding preparation. First, ensure that the welding materials match the main materials of the steel box girder, and they can be used only after passing chemical composition analysis and mechanical performance test upon entering the site. Entering the site. Second, accurately precise and clean the welding groove to ensure that the dimension is compliant and the surface is free of impurities. Third, determine welding process parameters such as welding current, voltage, and welding speed according to material characteristics, and conduct welding process qualification tests if necessary to verify the rationality of the parameters. During welding, adopt reasonable welding sequence and methods to control the deformation. For long welds, segmented backstab welding and sticky welding are used to reduce shrinkage deformation caused by concentrated welding heat. For walls of symmetrical structures, symmetrical welding is used to offset welding deformation. Carbon dioxide gas shielded welding is preferred to reduce heat input. Arrange professional personnel for operation to avoid welding defects. Timely defect information after welding. If the deviation exceeds the allowable limit, flame straightening or mechanical straightening shall be adopted. Strictly control the flame temperature and mechanical strengthening force to avoid damaging the material or causing secondary deformation. Re-inspection shall be carried out after straightening to conform compliance. So, in summary, with the development of the construction industry, the construction scale and technical difficulty of long-span highway bridges have increased. The rational application of steel box girder assembly technical can improve the scientificity of construction plans and reduce the incidence of problems. Construction units must fully recognize the value of steel box girders and the importance of quality control, strictly follow relevant specifications and standards, strengthen the control of various links, and ensure construction safety and overall quality. At the same time, optimize control measures in combination with on-site actual conditions. Accumulate construction experience. Promote the improvement of steel box girder construction technology and quality control level, and provide guarantee for the high quality development of highway transportation infrastructure. Over the years, with our high quality products and professional services, we have won high recognition and praise from numerous customers. From the pre-product consultation to the after-sales service, we have made our customers feel completely at ease. This is not only our honor but also the driving force for our continuous progress. Whether you are facing a bridge construction project in complex terrain or have special requirements for products, we can provide you with tailor tailor-made solutions to meet the needs for various bridge construction projects. If you have relevant business needs, please feel free to contact us at any time. We look forward to working with you and welcome to stay tuned to our live broadcast. Thank you.